We'll be looking at matrices today, and they are a way to solve systems more quickly. Essentially, I should say that's one use of a matrix and matrices is to solve systems more simply. Okay, so just a reminder, this is what a system of equations is, right? So this is a system that has two equations and two unknowns, but we could have a system with 15 equations and 15 unknowns, and a matrix will help us solve that more quickly. So this is our goal for today, and we're going to just go through some examples. And what's going to happen today is we're not going to actually use the matrix to solve a system today. We're just going to go through some operations and how we work with matrices and define what they are. How do I name the elements in the matrix? So that's what we're going to work on today, just kind of the basics, and then we'll tie it into how do we use it to solve a system. All right. So a matrix is a rectangular array of real numbers. Okay. So I can just I'm going to put A in for now, but these can be real numbers. Okay, so it could be something like 2, 3, 4, and maybe it's got another one down here, 1, 0, -1. There's an example with real numbers. I'm just putting A's in here so we can name these things. So what this would be right here is called a row. All right, so the matrix has a row, and this would be row number 1. Okay, I could put in row number 2. And when I start to put in more rows, this will be called a column. Look, I could have a matrix that has only one row, and it still has columns. That would be column 1. All right, so this column right here is column 1. This would be column 2. This would be column 3. Now, how do I remember columns? I think like columns that support a building, right? They go up and down like this. So here's the ground. Here's your building. Up top, I don't know. It's got columns that support it, right? So columns go vertical like that. That's how I remember the columns go up and down. Rows go across. So this would be row 2. All right. Each individual entry into the matrix, that's going to be we can label it, and we can call that each spot we can name it using subscript, okay? And then we will call those things those are typically called elements, I like to call them. So there's other things they're called, and I'll probably change up what I call them, but let's look at this first element here in row 1, column 1. So I could call this, we usually write the row first. So this is row 1, and we write it in subscript, and it's column 1. All right, so that would be A11. Then I have this element would be row 1, but column 2. And this would be row 1, but column 3. This one would be in row 1, but we're going to call this column N because it's the final one. We don't know how many are in between there because I'm just writing a general matrix. So this would be column N. All right, so then in row 2, this would be element A subscript, row 2, column 1. Row 2, column 2. You might even see some people write these with parentheses between them, okay? It's not like 21, 22. It's two separate numbers. But it's a way so we can talk about the elements more freely. So now let's make a random row down here. If our rows kept going. We'll call this row M because we don't know how many are in between 2 and M. So this would be row element M, column 1. Row M, column 2. Row M, column 3. Row M, column N. So that's how we're going to refer to the elements or the entries in each matrix. All right, so that's just a naming thing. And a matrix is a rectangular array of real numbers. Remember, these are all real numbers. So like something like this. And real means it could be a square root too. Don't let that freak you out. All right. So each entry is written in this form like we just talked about. And that means its spot in the matrix is in row I and column J. That's how we can find where it's located. So in matrix A, what is the value of the following? By the way, when we write a matrix A, this is just some formatting stuff. Really, it would be A equals. We kind of write it in the middle like that. 4, -2, 1, 5, -3, 3. All right, in matrix A, what is the value of the following? So A, 2, comma 3. So that means entry, what's the entry in row 2 and column 3. I'll write it like that. All right, so row 2, column 3. Right there, it's 3. See how I find that? All right, so A11 is row 1, column 1. That's 4. Row 1, the next one is row 1, column 2. That should be -2. Then we have row 3, column 2. There is no row 3. Well, that's a mistake, or they're just showing you that there is no row 3. I feel like that was a trick question. All right, moving along. So we can talk about the order of the matrix, or like kind of the size, but the real name is order, okay? And it describes how many rows and columns the matrix has. So we're going to determine the order of each matrices. So this one has how many rows? It has 1, has 1, 2, 3 rows, and 1, 2 columns. All right, so that's going to be called a 3 by 2 matrix. We put rows first, and then we write columns second. We use the word by here, a 3 by 2 matrix. All right, so this one is a 2 by 2 matrix because there's 2 rows and 2 columns. And whenever that happens, we call that a square matrix. All right, this one has 1, 2, 3, 4 rows, but only 1 column. So this is going to be a 4 by 1 matrix. This one here has 3 rows and 3 columns, so that's a 3 by 3 matrix. And that's, remember, we call that square matrix, a square matrix. Okay, let's move along here. An augmented matrix. That's going to be a matrix derived from a system of linear equations, each written in standard form, x, y, z, with a constant term on the right. So here's a system, okay? And remember, we're going to use this to solve the system. Like, we're going to find the value of x, y, and z more quickly than we could if we had to solve this system by hand. You'll see that in class. We'll do one in hand. I'll do one by hand, see how long it takes, then do one with a matrix. So the augmented matrix, it's like we're making something that represents, we're making a matrix that represents this system. So the first thing is, let's make the coefficient matrix. So that's not with the answers, just the x, the y, and the z. And they have to be in order, right? So I put the 1 here because the coefficient of x is 1. I put a -4 here because the coefficient of y is -4. And then I put a 3 here because the coefficient of z is +3. So it goes in order, x, y, z. You could think of the columns instead of 1, 2, and 3 when you're writing them to represent a system. This is the x column, this is the y column, this is the z column. All right, and you take, this is like equation number 1, and you take the coefficients off of equation number 1. Equation number 2, the coefficient here on x is -1. The coefficient on y is +3. The coefficient on z is -1. And on the last one, the coefficient on x in our last equation is 2. The coefficient on y, there is no y, so we put a 0. And the coefficient on z is -4, so we put a -4. That's what we call our coefficient matrix right here. we're working towards the augmented matrix. So the augmented matrix, notice that our coefficient matrix is a square matrix, by the way. Our augmented matrix has your coefficient matrix, but then we put this little dotted line, and then we put in one more column of, we add what each equation is equal to. The 5, the -3, and the 6. 5, -3, and the 6. So this kind of reminds me of, just the setup, reminds me a little bit of like synthetic division, how we use that to represent actual long polynomial division. Let's take a look at what is happening here. So let me erase all this red here. So let's look at equation 1 and compare that to our augmented matrix. Right? We look at equation 1, that should match row 1 with those coefficients. And the dashed line is kind of like, the dotted line is kind of like the equals, right? So that'll be true of all of these. That's an augmented matrix. You put in your coefficient matrix, and then you put what each equation is equal to. We're going to be able to work with this matrix and more quickly find out what x, y, and z are equal to. Okay? And so that's going to be helpful, so that when you'll see when I solve it by hand from this form, the system form, that the augmented matrix will be much more quickly, and we'll look at that. Some things you need to know is you need to know how to do what's called row operations on an augmented matrix, or on any matrix. So you're producing a new augmented matrix that is row equivalent to the original matrix. Before I get into this, it's just saying, like, the way we would solve these equations is, maybe you want to do elimination, right? So maybe you decide, I want to get rid of the x's by adding these two equations together. If you recall from Algebra 2, before you add those two together, you're going to multiply this whole equation here by 2, so that this becomes a -2, so that when you add these together, they equal 0. That's what you're going to be doing essentially with elementary row operations. When you multiply a row by a number, that's like multiplying an equation by 2. You got to multiply every part of the equation by 2. So not only is this -2x, this becomes 6, that becomes -2z, and that becomes -6. And if you recall back to Algebra 2, that's kind of one way to solve a system of two equations. You could do elimination. So this is just like a construct to show how we can do some of those solving operations of systems, again, more quickly. So what we would do is, like, steps 2 and 3 would be what I just described. If I multiplied a row by -2 and then added it to another row to form a new row, that's like what happens when you solve a system of equations, all right? Another thing you could do is interchange two rows. Why would that be important? We'll see that when we learn what, like, echelon form is. So changing two rows just kind of means, like, I can just swap those two equations. I could put one on top of the other. It doesn't matter. It doesn't change the system. It's still the same equations. I just switched which one is first. All right, so these are some elementary row operations that we can do. Let's go ahead and practice or perform some of those. All right, so let's see. This one says interchange first and second rows. So we usually write an arrow to show that we performed a row operation. And now the second row becomes the first row. So I'm going to take this row and write it first. -1, 2, 0, 3. And then I make the first row, the second row, 0, 1, 3, 4. And the third row remains unchanged. So what I did there, keep in mind, is I just interchanged the two rows. So we usually will write what was the operation, the row operation that was performed. So we usually write something like this, like row 1 was switched with row 2. So you can tell the reader what happened. Okay? Why would you want to do that? Well, again, when we look at echelon form, one thing you want is you want to have the lower rows start off with zeros, essentially. We'll talk about why that is later. But that's just an easy way to get a 0 in spot 1, 2, right? So we wanted row 2, 1, right? That's row 2, 1. We wanted that to equal 0. An easy way to make that happen would be to switch the two rows. All right, so that's how you can interchange two rows. Now we're going to multiply the first row by 1/2. And so the way we'd write that is whatever our multiplier is, so in this case it's 1/2, we're going to describe that as 1/2 times row 1. That's the transformation that's happening. So if I multiply the top row by 1/2, I end up with 1, -2, 3, and -1. I just multiplied every one of these numbers by 1/2, right? Then I have 1, 3, -3, 0. Row 2 remains unchanged. I need different brackets. Then I have 5, -2, 1, 2. Row 3 remains unchanged. And that would be multiplying row 1 by 1/2. Here we go. This one wants us to do multiple things. So we're going to add 2 times the first row to the third row. All right, so I'm going to put our arrow. So we're going to multiply -2 times row 1, and we're going to add that to row 3. Whoops, I got to put the R in. All right, we're going to get a new 3x4 matrix. So what row, what I'd like to do is decide what row is actually changing. So it's going to be row 3 that changes because it says to the third row, right? -2 times the first row to the third row. So that means that the first row remains unchanged, and that's important to understand. We're not changing the first row. We're changing the third row. We're adding something to the third row, which will change the third row. So I like to, before I do any operations, recopy all the rows or columns that remain unchanged. All right, so now we're going to multiply row 1 by -2 and then add it to row 3. So I'm going to write -2R1 right here below row 3, so then I could add them. So if I take the top row and multiply by -2, I get -2. If I multiply 2 times -2, I get -4. If I multiply -4 times -2, I get -8. And if I multiply -2, oops, got the eraser on, -2 times 3, I get -6. So remember, this row right here just represents -2 times row 1, which is what I wanted to start. I wanted that right there, right? I need that, -2 times row 1. Now I'm going to add it to column 3. So now basically I'm adding these two numbers together to get my new row. 0, -3. Oh, this should have been a +8, sorry. Because a -4 up here times the -2, that would be a +8. So 8 and 5 would be 13. And then -2 minus 6 will be -8. So keep in mind that this is the row that changed from this original row. And what did we do to it? This is a description right here. That is our description of how we came up with that new row. Again, why would we want to do that? Well, we want, in this case, element in row 3, column 1 to equal 0. Because for some reason, echelon form, like we'll talk about why and what happens, echelon form wants zeros, like rows towards the bottom to start with zeros, okay? So now this is a fill in the blanks using elementary row operations to form a row equivalent matrix. So there's a thing missing here. So you're trying to figure out what it is that we did to come up with this new row here. So like where this 2 became a 0, this 3 became a -1, all right? And how the heck could we have gotten that? So it looks like we can take and multiply. It looks like let's look at what we did here. Like -2 times 1 plus 2. And that looks like that we can take to get this 0, right? So I'm going to say that 0 right here, this part. It looks like I took and multiplied the row 2 thing. So I multiplied the one underneath it. That's the row 2 entry. I said thing, sorry. Row 2 entry, which is 1. I multiplied it by -2. and then I added it to the original right there. So it looks like it's negative 2 times row 2 plus row 1. Whoops, I put a 2 there. It looks like that's what I'm doing. Let me check here. I came up with this negative 1 by multiplying negative 2 times row 2, so that's the 1 underneath it, the 2 there. And then I added to it the original row 1. So I'm going to add to it 3. And that is how I came up with negative 1. So it looks like this is the operation. I know this one's kind of hard to see, and I don't know that you'd be able to figure it out the first time you look at one. This was a pretty complicated one to figure out. Once you become better at row operations, you'll probably recognize that kind of quick. It's kind of weird the first time you see it. So I recognize that the way we came up with row 1, our new row 1 here, is we took the old row 2, we multiplied it by negative 2, and then we added it to the old row 1. So if I do that now, I take the old row 2 and multiply it by negative 2. So 0 times negative 2 is 0. And then I add it to the old row 1. So 0 plus 1 is 1. So that will be a 1 that we fill in there. Again, that was pretty intense. We'll get better with something like that the more of this we do. What happened to change these? Well, you can see that row 2 didn't change. So how did we get from the old row 1 to the new row 1? It looks like we just divided by 2. So it's going to be 1/2 times row 1. Because I noticed 5 divided by 2 shows up here. And I know 2 divided by 2 shows up here. So it's going to be negative 4 divided by 2, which is negative 2. Now we're going to get into echelon form. We'll do that in class. This is going to have to be a class discussion. We'll finish this up in class.